Welcome to a fundamental concept in computer science, stacks and queues, which are essential abstract data structures used to store and manage collections of data efficiently, helping programs organize and retrieve information with ease. These abstract data structures are crucial for beginners to understand as they help organize information in a structured way, making it much easier for computer programs to process, store, and retrieve data effectively in various applications. Let's start with stacks, which operate on a principle called LIFO, standing for last in, first out, where the most recently added item is the first one to be removed from the structure. Imagine a stack of clean white plates in a cafeteria. You always add a new plate to the very top, and when you need one, you take it from the top, just like in real life. This LIFO principle ensures that the last plate you put on the stack is indeed the first one you take off, maintaining a strict order of access from one end only. In programming terms, adding an item to the stack is called a push operation, and removing the top item is known as pop, both of which are fundamental to how stacks work in code. Other key operations include peek or top, which lets you view the top item without actually removing it and is empty, a simple check to see if the stack currently has any items stored in it. All these operations on a stack are incredibly fast and efficient, typically taking constant time, which is denoted as O in big O notation, making stacks highly performant for real-world use. Real-world examples of stacks include the undo and redo functions in text editors, like Microsoft Word or Notepad, where each action you perform is pushed onto a stack, and Ctrl+C pops the last one to undo it. Your web browser's back button history is another great example. Each new page you visit gets pushed onto the stack, and clicking back pops the most recent page to return to the previous one. Function calls in programming languages, such as in Python or Java, also rely on a call stack to manage the order of execution, where each recursive or nested call pushes a new frame and returns pop it off. Now let's transition smoothly to queues, which follow the opposite principle called FIFO, standing for first in, first out, ensuring fairness in processing order. Think of a line of diverse people waiting patiently for a bus at a stop. The very first person to arrive in line is the first one to board when the bus arrives. You always join the line at the back or rear end, and people leave from the front, mimicking how data enters and exits in a queue structure perfectly. In programming, adding an item to the rear of a queue is called enqueue, and removing from the front is dequeue, standard terms used across languages like Java's queue interface. Just like stacks, queues provide front to peek at the first item without dequeuing it and is empty to verify if the queue holds any elements at all. These core queue operations are equally efficient, achieving constant time complexity of O on average, which is why they are preferred for many buffering and scheduling tasks. Common real-world uses for queues include printer queues in offices, where multiple documents wait in line to be printed in the order they were sent to the printer. Customer service lines, whether physical like at a bank or virtual like phone hold times with estimated wait displays, are perfect everyday examples of queues operating in action. Queues are also fundamental in graph algorithms like breadth-first search or BFS, where they help explore networks level by level, starting from a source node outward. So, to summarize clearly, stacks follow LIFO and allow access only from one end, specifically the top, making them ideal for reversible operations. In contrast, queues adhere to FIFO, accessing items from two distinct ends, the front for removal or dequeue, and the rear for addition or enqueue. Both stacks and queues are linear data structures whose size can grow dynamically, often implemented efficiently using linked lists or dynamic arrays in languages like Python. Their remarkable efficiency, with most operations at O-time complexity, is what makes stacks and queues incredibly valuable foundational tools throughout computer science and software development. Understanding these core concepts of stacks and queues is a crucial first step for any aspiring programmer or computer science enthusiast starting their journey. So keep exploring these ideas, keep practicing with code examples, and you'll master stacks and queues, along with many other foundational concepts, in no time at all.